Hello everyone, welcome back. And in this video on Microscopy Image Browser, I would like to show you how to install and how to use Segment Anything model version 2 from Meta AI. Segment Anything model version 2 is available from end of summer last year, and then the main strength of this model is that it's extremely fast and allows to do real-time segmentation of videos. But in our case, what we'd like to do, we'd like to use this model for segmentation of 3D datasets. And today I would like to show you how to do the full installation and then how we can use it. But before we start, let's take a look how we can proceed with it. Here is a dataset of mouse intestine tissue crypts, and it was taken with serial block phase scanning from microscopy. This is like 3D volume. And what I do here, I select my Segment Anything model as my segmentation tool, and as the method I select Interactive 3D. So let me zoom in somewhere. Let's say I want to get this nucleus, so I just click on it. And first the model gets initialized, and then it does the actual segmentation. Now this nucleus gets segmented using the left mouse click. If I want to add some area to the segmentation shape, I can use shift click, and then in this case that area will be added to my segmentation. If I want to exclude something, I can use the control click, and then that area will be excluded. So by using this shift clicks and the control clicks, I can actually fine-tune the shape that I want to segment. Let's take a look, for example, on this mitochondria. So I click on it and the mitochondria gets segmented. Then I scroll, and then I should do shift click, and then the Segment Anything starts to do segmentation in 3D. And you see this mitochondrial profile gets segmented. Let's continue from here. We scroll to this point, and then here you can see the progress, and then you can see that this mitochondrial profiles get segmented into the volume. Let's add this piece and let's scroll it to the beginning of it, shift click, and now the full mitochondrial profile basically is segmented, and I can add it to the model. Let's start with the installation process. In order to install, you need to get to main MIB website, mib.helsinki.fi. Then you need to go to downloads and the system requirements. In this section you can find instructions how to install different add-ons for MIB. And one of these is Segment Anything model here. When you get there, there will be 3 tabs, and then the tabs on the right hand side show you how to install Segment Anything 1. But what we're gonna do, we're gonna go Segment Anything module 2. I would recommend actually to use this one instead of Segment Anything 1, because the actual installation instructions are way simpler and more straightforward. Well, if you scroll through this text, there is the general information with the links on the Segment Anything module 2, the publication, the reference. And then when we get to the requirements, it's important to check what MATLAB release do you have. And it's important that you should have release 2022b or newer, and then you need to install Python which is compatible with specific release. If you click on this list link, it opens a MATLAB website where you can see compatible versions of Python for each version of MATLAB. For example, release 2023a is compatible only with Python 3.8, 3.9 and 3.10. If you have Python 3.11 or 3.12, it won't work with that release. So you need to make sure that version of Python that you're gonna install is compatible with the MATLAB release. Okay, and then for the best you need to have CUDA compatible GPU, otherwise it's going to be very slow, and I probably won't recommend it in this case. It's also possible to install on Linux. The instructions are pretty much the same. There are a few nuances, such as the locations are different, and then you would need to copy YAML config files in Segment Anything module 2 installation from the config folder into the main folder where it's installed. There are additional instructions should be below. Before we start, we need to check what kind of CUDA Toolkit version we have installed. One of the easiest ways just to check it from MATLAB. So if I start release 24B, that's the one I want to use now. And when I get there, I should just type GPU device command in main MATLAB workspace. And then it will show these the GPU device that I have. So I have NVIDIA GeForce RTX 3080 Ti. And within this list, I click here, all properties, there should be toolkit version. And now I have the toolkit 12.2, which means that I can really use, when I'm gonna be installing PyTorch, I can install any of PyTorch which has version 12.2 or below this. If you don't have MATLAB, you can also check it from standalone version of MIB. I can show you how to do it. So I just start MIB, and what you can do, you can go to deep MIB using this location. So let's see it get started. Then I go to tools, deep learning segmentation, and here there is the question mark button, and if you hit this, to show you the information about the GPU, and here should be toolkit version here 12.2. So that's how you can actually check which version of toolkit you have. The next step is to install Python. It's possible to use Miniconda, and it's possible to use Miniforge. These instructions that I have here, I adapted to use Miniforge. Let's go first to this Miniforge releases. So this is pre-release. Let's just take some latest release here, and I'm on Windows, so I will need probably this one, 24.11.3.2. Let's just download this. I will download it to my Python folder, and let's get there. Yes. So you can see already I have the previous version that I was using before, but let's just delete that and I will use this one. What I do now, I'll just start it as admin, but you can also install it as the normal user. But with admin rights, I think it's a bit easier because you can install it for everyone on the workstation, and you also kind of configure it. If we go here, we just follow these instructions. In the beginning, it will ask whether you want to install it just for yourself or for all users. Let's get here. I will install it for all users because I started with admin privileges. Then locations, I typically put it into my D drive into the Python subfolder, the Python, and then I'll make, well, I don't know, I think I put here Miniforge. Okay, let's put the same name, Miniforge, and hit next. Then here I create shortcuts, register Miniforge as system Python 3.12. Here you can see that what it's gonna do, it will install Python 3.12, which is not compatible with MATLAB, or it's actually compatible with my release, but maybe not compatible with any earlier releases before this 24B. But we will create environment, and then in the environment we will use a different version of Python. So I make sure these are all checked and I hit install. Then the next thing, what I typically do in these cases, I actually make sure that I make environment directory available for all users. In this case, it's very straightforward to add up for people their own environments without any administrative privileges. Let's just wait until it gets installed. And then the idea is that we have the basic installer, but then on the top of that we'll actually create environment inside of this Miniforge, and then this environment will be suited for our specific needs on using segment anything model with MIB. Now it's completed, we finish this. So I go inside of this Miniforge and environments. I just right click on that and then go to the security users, and I will edit it and then I just make sure that this folder is readable and writable for all users. Apply. Okay. Okay. So this is this optional node. If you without admin, so these you just follow these instructions in this section, it will install it inside your own user directory. Right. Next thing, what we need to do, we need to download Segment Anything Module 2. There are two sources of this. First of all, of course, you can install it directly from Meta AI GitHub, but the problem that I have to modify code so that it works with the 3D mode. It's not super difficult if you actually downloaded it from Meta AI. You can follow these instructions how it could be modified, this function. But the easiest one is just to get this fork distribution. So what we're gonna do, I just click here, open a new tab, I go to the code, download as zip. So then I save it. It's actually this one. Well, it matches the probably, well, I don't know, let's just delete this one. So this is the one I just downloaded. And then what I need, I will unzip it into this examples folder in my case. So I have Python examples, and I just unzip segment anything 2 into that folder. So that's what we did now. You can also get it directly using git command, which is explained here, but I found this way is quite straightforward and easy. Yeah, well, for Linux users, inside of this segment anything 2 main, there is a folder with configs, and then what is needed, these configs needs to be copied into the main folder, into SAM2 folder, into here, so that they will stay sort of as here. So I will need to copy these guys there as well. Otherwise, it's for some reason those configs can't be found on Linux. Maybe it's fixed already, I'm not sure, but it was the case before. Now we need to configure the environment. So we go to the start menu and then we type Miniforge and start Miniforge prompt. So we're now in the base, and now what we want to do, we want to create a new environment, and then when we create environment, we can specify the version of Python that we want to use. So let's take this 3.11. I think these are the correct paths in my case. I basically can copy paste this command here, and if I go back to the Miniforge environments, the environment will be created here. It will download Python 3.11, create environment, which it will be the environment name will be SAM for MIB with version 3.11. So we say yes to proceed. You can see now this environment appeared, and now it gets filled with all dependencies. It may take a while, but it's not super long. It's done. Now we need to activate this environment to make sure that we are not in the base. So I just copy paste here, activate SAM for MIB. And now you can see it's activated and then it's highlighted here. Alright, so now the next step would be to install require all dependencies, starting with the PyTorch. So the PyTorch needs to be configured. And remember what we did first was we checked what kind of CUDA version we have. And then I'll go to this PyTorch.org website. And here there is this configurator. I can select whatever release I want. And in this case, they have 12.4 CUDA, but as far as I have 12.2, let's just install this 11.8. And then what I do, when you press on this, it generates this command that needs to be executed. So I just copy this command and paste it here. Okay, let's close this, let's close that. Okay. The next step will be to install a few additional dependencies, such as hydrocore and then IO path. And in order to do that, we just basically will run these two commands after this one. And I think this is pretty much the whole installation from the Python side of things. Let's just wait a few more minutes or seconds until the PyTorch installation is finished. Now PyTorch has been installed, and then we can add a few extras. Hydrocore, and then IO path. Next step would be configuration of MIB. So you start MATLAB. Well, okay, I have it already started. Then I start MIB, typing MIB in the command prompt. Before I do it, make sure that you're in the location where MIB was downloaded. So now we have it here. Okay, then we go to the preferences. Let's just make it a little bit smaller so we see that. So we go to menu, file, preferences. Within the preferences, there is a section which is called external directories, and in this external directories we need to specify locations of where we have our environment. You can see now that previously I have Miniconda 3.11 installed, but now we installed Miniforge, and we need to specify this environment from this recent Miniforge installation here. Then I go D, Python, Miniforge, environments, same for MIB, and select Python. If you're on Linux, then you just make sure that all files is here. Otherwise, you won't see it because on Linux it's not executable. The next step is that so we specified this. Then what we need to do, we need to specify location where we put our networks. The networks that Segment Anything model will be using are automatically downloaded on demand, but then they store it in some location. And that's what you can do. You can specify one location, and then when you have multiple users, they will all have access to that location and will just use it. In my case, I just have the ctemp dipmip folder, and I press OK here. Now we go to the Segment Anything tool in the segmentation tools. Here I have different options. So if this SAM2 checkbox is disabled, then microscopic image browser will use Segment Anything model 1. If it's pressed, then it will use Segment Anything model version 2. What we need to do now, we need to go to the settings. So I select SAM2 here and then press this cogwheel settings button. And then in the settings button, I would need to specify the type of the backbone with the one that I want to use. You can see here, so there is version 2 and there is a version 2.1. I would probably use version 2.1 because it's newer and I believe it's better. And then within each of these versions, there are 4 different network types. And then what you can see, they change by their size. So the bigger, the larger is this value, the more GPU memory it will use, the more parameters it has, more powerful it is, but then it will potentially require more GPU memory and will be slightly slower. But in my case, I can really afford to use this one, so I just press this one. And the next thing I would need to put to specify location of my Segment Anything 2 installation. Well, because I used it before, so it's already predefined. But what I need to do, I need to paste the location where we unzipped it. And in my case, it was examples, Segment Anything 2 main, this one. Well, and then I can just basically put this location. I can also press this checkbox here, and then when I press OK, it will open directory selection dialog. So let's do this. I press OK. So we go to examples, segment anything to main, and then select folder. So we've got the backbone, then we specify the location, and then we specify that we have the CUDA version to use. So that's pretty much all about the installation. Let's test it. So now it's everything is specified, and then what I can do is just use left mouse click. What happens is if everything is set up correctly, then it starts Python environment, and then gets initializing segment anything 2.1 version. And then if everything works fine, we should see that this part gets segmented. Then if I want to increase my selection, I hold the shift and click, and then it will get expanded. And I click the control inside here to make sure that it's a little bit more fine-tuned to the specific needs that I want. Before we finish this, let's also take a look how we can add segment anything 1 installation, and also let's take a look on the few other things that we have here. So the documentation can be found if you just basically press this question mark button here. It should open the corresponding page for segment anything module 2 with all possible instruction and explanation, but we will also cover that a little bit in this video. By the way, what you can see, it's updated help, which has a bit better layout than the previous one, and then there are lots of different examples and then things within this. Also, what is different from segment anything 2, especially, that you can actually link any segment anything type of modules dynamically into MIB. To do this, what we need to go to resource folder. I will go to my MIB installation, and then there are resources, and within these resources there is 2 JSON files, SAM links and then SAM2 links. So if I open SAM2 links, you can see the example of sections which needs to be specified in order to automatically get any newer or any other trained model in order to be used with MIB. So for example, what it needs to be, there are all these fields are actually explained here, but kind of the idea is that you need to provide the checkpoint, link to the checkpoint, which is this PyTorch file, and link to YAML config. So there are like possibilities to specify 2 URLs. If one of them is, for some reason is dead, then the other one will be used. But this is more like an optional. Now let's actually add segment anything 1. In order to do that, we go back to this Miniforge. We still have SAM for MIB activated, so we don't have to do this activation step. Then what we need is just to add this open CV. Let's just add that. Now we will, now we will add picotools. And then we're gonna add on an X runtime GPU. The difference with the segment anything 1, I'm for some reason made it via on an X format, so it's a little bit messier than segment anything 2. Well, if you don't really want to, if you want to use segment anything 2 without MATLAB or MIB, there you may need to do a few additional steps in order to do some compilation. And then instructions for that are below in this document. So now it's installed as well. Oh yeah, of course we need to download it. In this case, what we do, we go to segment anything on Windows, and then we need to download it, and then you can get either forked or directly from Facebook research. This is segment anything 1. So you download zip file and then you unzip it somewhere. And then in this case, I uncheck this checkbox, go to the settings. These will be like a different settings, and these settings will be for segment anything 1. you again can select different backbones, including the compiled version of micro SAM for various light and electron microscopy. And then here you just need to specify location for segment anything 1. And you can do again the same trick. You can press this checkbox, press OK, and then you can specify segment anything main folder like this. And now I need to go to this interactive, and then let me press C to clear, and then when I click, it will start segment anything 1, and then hopefully do the similar segmentation as we've seen before. But from my experience, it's a bit slower, and yeah, well, it's not really implemented for doing things in 3D, so it's more like interactive 2D approach. Let's see if it got activated. Yeah. So again, I can use Shift and then Control clicks in order to provide positive and negative seeds, and then it will actually do segmentation for me. Let's now take a look on different modes and operations that we can use with segment anything 2. I'll switch back segment anything 2 by checking this checkbox. And here we have 4 different modes: interactive, interactive 3D, landmarks, and automatic everything. The major ones that we're gonna typically use is interactive 3D, but from my recent experience, I found that interactive 3D is the most convenient actually mode to use. But let's actually start with interactive. And let's load the dataset. So this is the same dataset as we started. It's the mouse intestine crypt taking the serial block face ASIAM. We can actually close this one, we don't need that anymore. And I will switch on as well the overlay that you can see what kind of buttons I'm pressing. First of all, here in the segment anything interactive mode, you can specify 2D or 3D stack. So if you have 2D, it works as the segmentation of objects in 2D by getting the seeds. For example, let's start and try to segment this nuclei. When I change the mode, or when I switch the SAM 1 or 2, it removes the Python environment, so it get initialized again when I start using this. And the reason so it's done to release a little bit memory on the GPU. Let's press plus to add a new model. We call it nuclei, and then I hit A to add. Let's go next one, hit A, next one, hit A. What happens here, when I click, the object starts to get segmented. I can use shift click in order to expand my selection, let's say for example towards here, and I can use the control click to provide a negative seed, and that area is removed from the segmentation. I can also press this autofill button, which I probably recommend, and what happens in this case, it kind of fills the holes in the segmentation area. So for example, you see here this area is there's a hole, but let's say if I don't want to have it, and I click again in the first and then the second, and you see that area gets filled, and I provide the control click to exclude that part from the segmentation. So sometimes there are small holes appearing when the models are used, and then you can a little bit tolerate this by having this autofill checkbox. You see that the result of the segmentation is shown in green, and this is because our destination is selection. For example, if our destination will be the mask, if I click, then the result of the segmentation will be not the selection layer, but the mask layer, which is shown in magenta. Let's take a look on the other one, for example here, and then control click to exclude the central part, and you see it has this magenta outline, which is due to the mask layer. Let's make it a little bit less transparent. The same could be done if I change it to the model. So in this case, what it will do, it will directly send it to the model. For example, if I click on this, but you see what happened, the previous things that I had in the model disappeared, and this was because my mode is replaced. So let me press Ctrl Z to undo. Now what I can do, I can change the mode from replace to add. It means that each next click will actually add my material to the model instead of replacing it. And that way I can continue segmentation of nuclei by just basically clicking into them one by one. So this is like interactive 2D mode. There are a few other options. For example, I can subtract. I think this is not really useful that much, but for example, if I subtract, if I click on this, it will subtract it. But of course, there are a few other things, so I actually have to probably click here, click there to exclude all the small pixels. The mode is there, but in reality, it's not really useful. There is another interesting mode which is called add plus next material. And then the idea with this is that, for example, let me just duplicate the data set. I'll make a new material, and then I'll make it 65,000. And the idea here is that what I want to do, I want to create instances. For example, let's say I want to segment these lipid droplets and I want to have them as individual instances. What I do, I click on the second material here, right mouse button, and then rename and name it 1. So this would be the first material. And then I change the mode add plus next material. When I click on my object, what it will do, it will assign this object to index 1. And here you can see after a slash it will show index of material. Now it's 1. And then it generates the next material index. Then I click on this, it will be 2, 3, 4, 5, 6, 7, 8, 9, and so on. It's also compatible with the Shift and Control clicks. For example, let's say I want to take like these three together. I click on this, I hold Shift, Control, and then it will combine this all together. And also I can press still Ctrl Z to undo selection of the whole area. So in this case, I can basically continue this. So this add plus next is very suitable for the situations when we need to create individual instances. Then it works pretty much kind of automatically. And the only thing here which you can potentially benefit is having this checkbox, fix selection to material, and have it on exterior. It means when, for example, let me just uncheck this. Let's say I click here, you see it actually overrides everything. So I Ctrl Z, but then what I can do, I can fix material to selection, exterior, and then when I click here, what it will do, it will generate a new one, but it will never overwrite the existing materials, which sort of would be useful when the objects are not as well defined as these lipid droplets. Okay, let's close this one. Okay, return back here. Okay, so let's see another mode which is actually here, but I do not really recommend it that much, is the 3D mode. And the idea is that you go to an object, you click on this, then, okay, I need a little bit shift here, then I scroll and I hold and press shift click. And then what it actually do, it makes this kind of 3D segmentation. So the click, where I click, this point gets interpolated through the volume, and then it will provide the seeds. And then the seeds will be used in order to get this segmentation. So let's say if I want to continue, again, I click here, scroll, shift click, and then it will continue the segmentation. So now my destination is model, and then it kind of replaces everything which is there. I would typically do this 3D perhaps more like via selection, but I think it depends a little bit how well the structures gets identified. There could be a little bit of lag at the end of this series. Like for example, let's say I start from here, scroll a little bit further. Let's see, so it processes them like one by one, but then when it reaches the end, this progress bar disappears. But then there is a bit of lag for a few seconds that it sort of doesn't really react. So this is a bit of annoyance. And you can also see if, for example, when it was interpolating the seed end up into this region. So it sort of doesn't really, it wasn't super nice. So I would actually have to go back here and again do a few other clicks, maybe change the mode to 2D, and then a little bit modify these areas manually. In that sense, the next mode, which is interactive 3D, is way more powerful. In this mode, what is needed is that you go to the first slice wherever you want. Let's say we want to go to this nucleus. We click on this. Again, because I changed the modes, it needs to reinitialize the Python environment. Okay, so now it's reinitialized. Now it's selected. Let's press shift click here to make a nice shape. Maybe I click Control outside. Then I scroll. Let's say the nucleus ends here, and I shift click on it. Now you can see the progress here. So it takes about 10 frames per second. And then you can see that the new segmentation is right there, and I can add it by pressing Shift A to the nuclei. So now it's there. Let's see, let's take something more complex, for example, mitochondria. I press plus, make a new model, material mito, and then let's zoom in somewhere here, mitochondria. I scroll where it goes, for example, up to here, shift click. And then I press Shift A to add. Also, because we work on this kind of constrained area, you can benefit from using this block mode switch, which will only adds up the pieces which we see now on the screen. Let's say I go here and then I scroll the other way, well, maybe until the moment when they get merged with the other one, and then I press Shift A, and then I can do this one, Control click here. Not sure. Okay, maybe that was the correct selection, and maybe I will go. Oh, this is quite complex shape. I would keep actually the things a little bit like more simplistic shapes, because otherwise it gets really confused. And then usually you combine the things from multiple. Like you see now, I can get this one, and then when they actually separate, okay, there was a small fragment here at like now this shape is separated, so I can actually click here. Let's put Control click here, and then I scroll where it goes, for example here, and then shift click. And you see it can follow quite nicely complex shapes. And then if something needs to be cleared, I can still start, for example, I can click on this if I would really want to correct things on like one single shape, and then hit A and then Shift A to add them all. The next mode is called landmarks. The landmark mode is it's a little bit different. I think, I'm not sure I made it in the beginning, but now I felt that this 3D mode, interactive 3D, is sort of better. But the idea with the landmark is that we can provide the positive and negative landmark. So I click, and then it says the value 1, which means a positive seed, and then I can scroll. Oh, sorry, I just have in my settings, not here, on this one, it shows the for multiple slices. So I have this seed here, and then I scroll and I shift click, and then you can see that this seed was interpolated for all slices. Now what I can do, let's try if I just actually press segment here, whether it can do something. Again, because I changed the method here, it reinitializes Python environment. So you see it gets segmented, but now because I have 2D slice, it's only segmented on one slice. Now what I can do, I can press 3D stack and press segment, and now it will follow through all of the seeds, and whenever on the slices where I have the seed, it will actually do the segmentation like this. And I can add it to now to LD, which is leaping droplet, Shift A to add, and then I can go give fix selection to material, LD. Let's take this one. I can press this to wipe them, so it will remove all the seeds. I click on this. 1 is the positive seed, scroll up to here, shift click, now it's populated. Then I can provide negative seeds. For example, I go here, I press on this, I put 0, which is negative seed, and then I scroll to here, and then shift click, and then this seed will be interpolated. So you see here 1 is the positive seed and 0 is the negative seed. And then now if I press segment, then it will use both of these seeds in order to identify where is my object. Yeah, it could be a little bit lag as well. And then I can add it to my lipid droplets by holding and pressing Shift A. And finally we can test the last mode, which is called automatic everything. I do not super recommend this because I think it's slow, and then because it's trained on natural images as dogs and cats, does not really work very well for ultramicroscopy images unless there are some very specific structures, as perhaps the lipid droplets. Because this is quite big image, and I didn't put any tiling to process this. It won't work well for this big one. So instead, what I do, I will zoom into a small area and turn on this block mode switch, so it will only process this image that I have in the view. And I press create, make a new model. It needs to be the 65,000 materials, and then I press segment. So the Python environment gets initialized again, and then it starts segment everything in this automatic mode. I think it's a bit slow, but because I haven't used I haven't really fine-tuned it. Perhaps I have just some issues on the way how I implemented this part. Okay, well, so this is the kind of result. You can see that it was able to identify the lipid droplets. Well, there's still some bugs. This is more like a shape of the cell. This is nucleus, a few other things. Let me toggle the view. I can't toggle this. Oh yeah, so you see, I remember there was a bit of delay on things. Well, so it gives you something, but I don't think that this something is super useful. So, but with some, it's actually possible to fine-tune the things a little bit with these parameters, but I haven't played that much with those. With this, I would like to finish, and I would like to thank you for attention. I hope that this segment anything model was useful for you, and then at least in our case, it really dramatically speeds up the segmentation and preparation of training sets for deep learning trainings. Thank you very much again, and goodbye.